For Module 4, we covered redox reactions, and we looked at the reduction and oxidation reactions of a couple different examples, but we didn't look at examples exactly like this that you see in the homework. So I wanted to make a quick video to kind of help you see redox reactions. And the first one, we've got chromate reacts and it becomes dichromate. And so to figure out if this is a redox reaction, we kind of have to assign charges. And this is what we didn't go over in class. It's kind of how to assign a charge in these cases to see if redox is taking place. And so if we look at chromate, we got CrO4 2-. We can break this up and see that I've got a chromium there, and then this subscript 4 tells us I've got 4 oxygens. Now we want to figure out the charge on the chromium so that we can say, is this a redox reaction or not? And to do that, well, we know oxygen is always 2-. So I've got a total charge of -8 from oxygen. And now the next part is a little bit different than what we did for ionic compounds and trying to figure out the charge on the transition metal, because here the charge on chromate, the polyatomic ion, the overall charge is -2. So that means the charge from chromium needs to be +6 to balance it out, right? So chromium is 6+ in chromate. So next we want to look at the dichromate to see if there was a redox reaction, the charge on chromium would have to change. So we can break up the dichromate the same way. We've got Cr2O7 2-. We break it up. I've got 2 chromiums. I've got 7 oxygen. Again, oxygen is 2-, so that's an overall charge of -14 from oxygen. The charge on the dichromate overall is -2. So that means I need to have a total of +12 from chromium. That's spread out over 2 chromiums, so each chromium is 6+. So this is not a redox reaction because chromium goes from 6+ to 6+. It does not change its oxidation state. The next one, we've got sodium carbonate reacting with phosphoric acid to make disodium hydrogen phosphate, carbon dioxide, and water. This is also not a redox reaction. This is an acid-base reaction, but we can still assign the charges to see that that's the case. So we start with carbonate. Carbonate, right, we take away the 2 sodiums. I've got carbonate, CO3 2-. This breaks down into carbon and 3 oxygens. Again, we know oxygen is always -2, so that's -6 from oxygen. The overall charge on carbonate is -2, so carbon in carbonate needs to be 4+. We would assign it a 4+ charge. Carbon dioxide, we can break that down the same way to see if this is a redox reaction or not. So I've got 2 oxygens at -2 each, that's -4. The overall charge on carbon dioxide is 0, so we would call oxygen here, the carbon here, 4+. And so again, we can see this is not a redox reaction because carbon in carbonate is +4, and then carbon in carbon dioxide is also +4. The next reaction, copper sulfate, reacts with zinc to form zinc sulfate and solid copper. This is a redox reaction. So one clear sign is anytime we have something that's aqueous that ends up a pure elemental solid, or an elemental solid that ends up aqueous, ions in solution, that's a clear sign that there was a redox reaction in this case. So in copper sulfate, we know that sulfate is 2-. Copper sulfate needs to be neutral overall, so that gives us a 2+ charge on copper. We end up with elemental copper, so we end up with elemental copper would be copper 0. So for this reaction, copper goes from 2+ to copper 0. How did that happen, right? To balance that out, the only thing we have to work with are negatively charged electrons. So that means I can add in 2 electrons here to take copper 2 plus to copper 0. And something that's adding electrons, right? Reduction is the gain of electrons. So this is not only a redox reaction, we're looking at the reduction of copper. The next one is also a redox reaction. We're looking at methane to carbon monoxide. So here we can break up methane into carbon and 4 hydrogens. Hydrogen would be a +1 charge, so 4 times +1, 4 plus on the hydrogen, which means carbon would need to be 4 minus, because overall methane is 0. So we go from methane to carbon monoxide. Carbon monoxide, oxygen is 2 minus each. All right, so I've got 1 oxygen, that's -2. Carbon monoxide is neutral, the overall charge is 0. So that tells us that carbon here needs to be 2 plus to balance that out. So how did this happen? How did carbon go from 4 minus all the way to 2 plus? Right, it had to have lost 6 electrons. To balance this out, right, I've got -4 here, which means this side needs to be -4. +2 -6, the overall charge is -4. And so in this case, we did have a redox reaction, and in this redox reaction, carbon was oxidized.